Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about space news that happened before 14/03/2025. So let's dive deep into it. So first weird news is intuitive machine number 2. So this puppy was launched on 27 February 2025, 16-minute universal time coordinate. It touched down moon surface on 6 March 2025, 1728 universal time coordinate. And unfortunately it fell over. Basically exactly the same thing that happened in IM1. And this time it was worse. So you have to understand the series of event that happened was basically they had a very high quality LiDAR on this puppy. Now, because LiDAR that are meant for space and especially for celestial navigation, they are very high power laser, meaning they are not eye safe. So whenever people are working on it, there is a key into LiDAR system. That physical key stops the power rail to connecting to basically optics laser array. So no matter what you do, no matter what software command you give, the key will block it, meaning that's a physical check. Basically how you fighter jets have now remove before flight. So there is that remove before flight. They forgot to remove before flight. So then you're like, okay, how the heck they did the landing? Well, they removed it and then they were like launched it. It was not removed. They're like, okay, we have a problem. Thankfully, one of the payload was a LiDAR. So they did the hot patch, basically figured out how to have a payload data directly going into the navigation center and did the software patchwork. It worked, but not great. Now, again, I do not blame if the software was not perfectly calibrated, because again, it was not meant to be used like that. So calibration was not right, and it crashed a bit harder, higher speed than it's supposed to. One of the legs just yeeted and then it fell over. Now, thankfully, even though it did fell over, the solar panel did had certain exposure to the sunlight, so it did work partially. So a lot of the instruments, a lot of the payloads could do some work, not a lot of but some work. This time it was bad. This time it is DOA, dead on arrival. So yeah, this time again they made sure that the LiDAR is working, the key was removed, everything is fine, everything is dandy, and the software pooped out and it messed up. So they crashed much higher speed than ever, basically what they should have. And again, the same thing, leg broke. And this time, unfortunately, the solar panel is completely downwards, meaning there is zero power. Meaning after landing, the battery started to drain. When it started to transmit data, it transmitted give or take 600 megabytes roughly, and then battery was kaput. Now, I have no idea. This is like almost too weird. Basically, you're supposed to build things for double redundancy, meaning if this fails, at least do something. So this one, they lucked out. They should have put solar panels again, one major solar panel, another smaller solar panels, other sides, because you do have one luxury. There is no night when you are landing on a lunar surface for that mission. So even if, as long as you can maintain the discharge current to be low enough, basically self discharge of a battery bank is, let's say, 5 watt per hour, it discharges by itself. As long as you can make sure that you are dumping more than that, like 6-10 watts, which again, enough surface is exposed where it could have easily had 5 to 6 watts of power continuously going into that. And again, that would have been for 15 days. They could have run a lot of instruments and partial work. They did not get to do anything this time. So yeah, that was dead on arrival and flat out kaput in few hours. So this was bad, and this is exposing two of the problems. The legs are not strong enough. Now you might be like, okay, how strong your legs can be? Well, the best case scenario would be a Falcon 9 booster legs. They are designed to go kaput and still manage it. And their leg, they broke first time, and it does not seem they turbocharged it too much, and second time also they kaput. So that is there. And the bigger issue is how the heck their software is not refined enough. Because be mindful, when something like this happens, you double check everything affecting it, which was navigation algorithm. So not good. So this is bad. And I'm reasonably sure if they have a third failure, they might not get a contract after that. So this is a unfortunate reality. We were happy about Firefly's landing. We were expecting this to be successful, but it did not. So this is not good. Then we come to another oops news, which is a Starship flight test number 8. Now, this puppy was launched on 6 March 2025, 23:30 Universal Time Coordinate, and the booster number was 15 and ship number was 34 Mark II variants. And Booster did a successful third catch, which, mind you, it's a very big deal that this is happening. This is a very big deal. And unfortunately, while this was a good yay moment, this was a nay moment. This is from a telescope. One guy actually managed to use a telescope to capture it. So it's like spinning around, and one engine actually yeeted out of there. One Raptor engine, while the ship was intact, just boom, out of there. So that, and this is from ISS, where you can actually see the gas cloud. So yeah, that was not good. And problematic part is, it's exactly what happened with last mission, only worst. Basically, the last mission they had fire, this mission they had fire plus kaboom. So this was not a okay system. Like eating an engine, not a good thing. So that's a really bad system. And be mindful, overall as a project, it does have money from other people, specifically NASA and other what we call gray market investor. Basically, people who deal with money can tell you what exactly they are called. And the fact this is number 8 and they still haven't reached orbit, because you have to understand, before they jumped to Mark 2, it was almost certain that they're gonna start deploying payload in orbit, because you have to understand, reusability of a rocket does not pay you money. Dumping payload into orbit pays you. So even if you have a rocket that is supposed to be reusable and it is not being reused as of now, you will still make some money. And of course, you that's exactly how Falcon 9 was delivered. Falcon 9 was a rocket first, then they launched it, then they tried to recover it. It went boom, I think 20 times or something like that. And then they are like, okay, finally figured out how to reuse it. That's normal. This is completely reverse. They're like, 8 times they have launched it and they haven't reached orbit, which, mind you, Falcon 1 reached in the 4th try. And Blue Origin managed to do it in 1 try. So this is not a very good show, because again, nobody cares 1 or 2 times. 8 times people are like, bruh, are you actually gonna do this? Because again, having same problem again and worse than last, it means there is a certain design issue. And the overall read of the situation is, this is the penalty of parallel development, where if you are developing everything without anything being finished, nothing works. It's basically like, is the booster ready? No. Why? Well, they have to redesign it when they have with integrated exhaust ring, basically hot staging ring. They have to integrate it, otherwise it's not a reusable system. Now why can't they do it? Well, they have to upgrade the engine. Which engine? You have to understand, Mark 1 engine was not useful as an orbital vehicle. If they had stopped it and just used Mark 1 engine, it would not have launched. It would not have reached orbital velocity. Mark 2 could have done that, but again, they did not stop at Mark 2. They are still working on Mark 3. And I'm reasonably sure some people are already saying there are Mark 4 variant under construction, meaning nothing is thoroughly done, where it's like, okay, this is the engine, let's design things around it. So they are not sure how many engines they're going to do. They are not sure about what diameter they have to do. They're not sure how what the final structure would be. If everything is in flux, nothing gets done. So that is what's happening. And again, 8, 1 or 2, who cares? 3 or 4, taking a bit of time. And like 8 is like, bro, like it's kind of a bit difficult to, like, you know, justify this project if like a test number 10 happens and they still do not have orbital reliability. Because again, reuse is not going to happen that quickly, and not having payload in orbit makes it kind of hard to justify. They can still focus on basically the booster, refine the booster, go to Mark 3 engines, and like, okay, booster lockdown, all the things, make a cheap variant of basically Starship that just dumps payload. And again, that way you will have the benefit of having super high tonnage, almost like, let's say, instead of 100 ton, almost 200 or maybe 250 ton, meaning you can easily populate the orbital shells required for Starlink. You can get a lot of stuff done very quickly. Everything would be easier, cheaper, get it done in a few months, and then you refine slowly, like, you know, your booster will be ready, and then you work on making Starship reusable. Directly going for that without having orbital payload delivery, yeah, that's the not the great part. So again, 8, that's why people are like, are you sure you are on the right path? Because again, if everything is unknown, time also becomes unknown. Now we come to another smaller success that India did, is a space docking experiment. Now you have to understand, India is doing exactly what China was doing, basically brick by brick test the technologies, small what we call pathfinder missions. So this is a small pathfinder mission. Basically, these 2 puppies supposed to get into the orbit, and they're supposed to get married, and they're supposed to get divorced, basically docking and undocking. And this was launched in 30 December 2024, 16:30 Universal Time Coordinate. And there was some hiccups during the first launch. As in, like, it was launched in the orbit, there was some calculations error and all that. They worked on it, and after that they did like successful docking happened and successful undocking happened, this basically. And this makes India fourth nation that can do this, given the fact the first was USA, second was USSR, and third was China. Yes, USSR did not focus on docking very early on. USA had to focus on docking. So that's a very big thing. So that makes India's basically missions where we are planning to have Gaganyaan, basically human crewed flight, far more reliable, far more achievable. Because you may think, okay, how hard is docking? Well, problem is vacuum. That makes it hard. Basically, if you have metal touching other metal, it will go through what we call cold welding. Basically, if surfaces are close there and there is no gas molecule barrier, electron will jump from one metal to another metal, and that is literally cold welding. You cannot detach it. It's like permanent gluing, and it's a perfect welding scheme. So you have to make sure the material is in such a way that cold welding does not happen. You have to have coating, you have to have dissimilar material, you have to do a lot of engineering to make sure that the marriage has divorce potential. Not like, okay, we got married, done sir, you can't detach it. That would be a disaster. So it is not as easy. While humanity has achieved it, there are two problems. First, the mechanical problems and all that. Second is the navigational algorithm. Now, like, okay, how the heck humans did in 1969? Well, we had these puppy and this millennial evolution. So this was running on God knows how many generation, few million generation. Our computers are not that good. So software part is, again, that required more of refinement. So we got the hardware, we are refining the software, and again, successful testing demonstration in space is a good thing, because again, two floating thing making love to two floating things, yeah, that's a difficult thing. And be mindful, if you do not dock with the right force, you could just push something out. So it's a very finicky operation. So again, achieving this, and given the fact there are almost 200 countries on this planet, I am very pleased. This is a small step, but again, leading to larger things, brick by brick, day by day. Then we come to another delayed issue, which is astronaut return is delayed again. Again, be mindful when you are watching this. Hopefully, fingers crossed, there should not have been a delay at that point. Butch Wilmore and Sunita Williams, they went there in basically 6 June 2024, 17:30. This is the time when they did this puppy. Their ride was on Boeing Starliner, but Boeing Starliner had an issue while docking, and NASA did try to figure out what the hell was happening, and the result was not good. And the problem with the result was they were not sure why the heck it was happening. That was the problem. Again, it's not like, okay, this is the fault, this is what we can do. It was uncertain. So they took a safer route and they detached the capsule, dropped it into the ocean. It worked. Nothing bad happened to that. But again, they were not willing to take a risk. And like, okay, what about supplies? ISS does have surplus supplies for this exact reason. And resupply missions are scheduled regularly enough that this will not be an issue. Minor inconvenience at best. So that did happen. They did had minor inconvenience for short duration before the resupply was done with extra supplies. Then timing was done. This rocket was ready to take it, bring them back. And unfortunately, this time, now rocket is tested, fully tested, time tested, take it and go. The Dragon capsule, time tested, take it and go. What failed was freaking hydraulic clamps. And the clamps that's supposed to grip the rocket. It was showing some erroneous reading. They're like, yeah, we cannot have. Oops. There. Now be mindful, worst case scenario, if this cramp would have caused an issue to the rocket, they would have ejected safely. But again, that shall not take oops. So they had to delay it. Hopefully, when you are watching this video, this delay would have been solved and next launch should have happened. When I'm recording this video, it has not happened yet. But it should have happened by the time you are watching this on Monday. Now, another small mission, which again, I have covered in detail, SPHEREx. This is basically James Webb Space Telescope is a sniper scope. It's a very high telephoto lens. It's like it looks in a very small patch, but very far. Like this puppy goes deep. Now, SPHERex is completely different. It's a wide angle lens. How wide? Well, this can picture the whole celestial sphere from Earth's vantage point every 6 months. Basically, if you look at into Orion Nebula and you're like, okay, let's look at Orion Belt, every 6 months you're going to get one photo. Cut, basically. And again, you can do that everywhere. Meaning, in few years, this puppy will give us enough time lapse for whole celestial sphere. That is magnificent. That level of resolution is like, whoa. So that is there. And again, I have full detailed deep down breakdown. I like the idea they have a bucket, another smaller bucket, and even a smaller bucket. So there are these 3 buckets that are making sure that heat does not go inside the material. Now it is cold, but not as cold as James Webb Space Telescope. Now this puppy, many articles will say 102 infrared colors. Now What does color mean? Now let this be very clear. There is no band. Basically, like how country border are not a realistic thing, unless we are talking about a river. Generally, country borders are arbitrarily decided by humans, not nature. Same happens here. All the lines that we have, basically line between microwave and radio wave, it's arbitrary. Line between infrared and microwaves, arbitrary. Line between ultraviolet and X-ray, all of these are arbitrary. See, only quote unquote natural thing is basically optical bandwidth. That bandwidth is limited by these puppies. These puppies have three sensors: red, blue, and green. Now they are not red, blue, and green. That's how our brain interprets it. Basically, that wavelength, our brain gives it a tag called it's red. That another wavelength gives it a blue tag. That's how it does. And again, you can make a sensor that has the right sensitivity and give it different color, and it will look almost alien-like, but it could work. So that's how you can have red, blue, green. And infrared basically means inferior than red. That's why it's below red, and ultraviolet is above that. Now infrared is a huge bandwidth. Basically, from the shortest wavelength to longest wavelength in infrared is huge. Basically, if you slice it exactly how we slice color spectrum, you will find you're gonna have way too many slices in that. So that's what people mean when they're saying like 102 slices infrared colors. You can have 10,000. That's not an issue as long as you have sensor that is sensitive enough, or basically band pass filter that is good enough. This puppy has enough resolution, and you have near infrared, you have mid wave infrared and far infrared, and basically near infrared to mid infrared, they have enough slices to actually capture it. And again, you do need cooling as you start to go into far infrared. So all these things does allow this puppy to capture celestial sphere with a time-lapse camera, and the whole sphere, meaning any astronomer in future can basically, hey, what is happening here? Okay, cool. Can you give me data going back slice by slice? Is like 6 months later, 6 months later, 6 months later. That's a very significant. And doing that in whole celestial sphere, that improves our understanding. Basically, it's photographing the whole forest, how stars are evolving, how nebulas are moving, how galaxies are moving. Not small things, not planets and all that, but whole larger structure. So that's why it's a very big thing. And it has been deployed in sun synchronous polar orbit to minimize interference from Earth itself. Now, the buckets are very good to make sure that sun's heat does not bother it, but Earth could reach a point where if orbit was not precise enough, that Earth's data will get inside the bucket. So they had to have this precise orbit, sun synchronous polar orbit, to make sure that bucket is pointed the right way. So this is SPHEREx. So this was my basically news summary of something recent, something big. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.